Hi, I'm here to talk to you about energy today, and I've put a couple definitions and several forms of energy up on the board. You might want to pause and write this down. The definitions that I have for energy, there's two of them. The first is the ability to do work, and work is a very specific term that I'm going to define later, but it basically involves moving objects a certain distance using a certain amount of force. And by using energy, you can actually move objects, which relates to the second one, the ability to affect change on the world around you. Energy is one of these really vague terms that we use in society all the time without necessarily understanding what it means. And what it means in physics is very, very specific. I want you to get the idea of work in your head, because we'll see energy and work are sometimes used interchangeably, and certainly they both use the same units, for example, and they have very similar meanings. So if you see work, you might have to think about energy, and if you see energy, you might need to think about work. Speaking of units, the units for energy are joules, and I'll talk more about that in a couple minutes. Kinetic energy is the energy of moving objects. So if something is moving, it has kinetic energy. The faster it moves, the more kinetic energy. Gravitational potential energy, which involves lifting objects off the ground. The higher I lift an object, or the more massive the object is, the more gravitational potential energy it has. An object that is on the ground has zero gravitational potential energy. Well, depending on how we define the starting point, I should say. Spring potential energy. Whenever we compress a spring or elongate a spring, I'm going to write elongate a spring. That stores some energy that we can use for other things. We're using this term potential energy to include stored energy. So potential means stored energy that can be used at a later date. So springs store potential energy by compressing them, and then if you let them go, it releases that energy and turns it into other forms. Internal energy is also known as heat or thermal energy. A lot of times if you rub your hands together, you'll feel friction, but you're also creating internal energy. This goes by the term, by the way, Q. So occasionally, but not often, you might see Q used to indicate internal energy. Electrical energy, for example, chemical potential energy. Potential, again, is stored, right? So chemical potential energy could be like batteries have chemical potential energy. You can have nuclear energy, energy that's stored within atoms. Light is a form of energy. Sound is a form of energy. So there's lots of different kinds of energy. There's a term that we use to group some of these too, and I'm going to just put a little thing around the three of these. Kinetic, gravitational, and spring potential energy. Those are all what are defined as forms of mechanical energy. And it's important that you know this, because there will be times when we talk about conservation of energy, and the conservation of energy usually just involves mechanical energy. And mechanical energy, just think about it, mechanical being like moving things. So these energies are all, these kinds of energies all have to do with either the position of an object or the motion of an object. And that's what mechanical energy is related to. I think that's it for now. Thank you very much for watching.